All right, so what we're trying to do on these problems is to match a parent function with a transformed version of it. So what you'll notice is that this graph, so our job is to put different numbers in here and we're discovering how functions shift. Hopefully we have a little background knowledge that the thing inside of here will cause the graph to go left or right, opposite of the sign. So whatever sign is here, it'll move opposite. So if you put a negative sign, it actually goes to the right. If you put a positive sign, it'll go to the left. So negative numbers cause a shift to the right, and a positive number causes a shift to the left. It's kind of the opposite of the way we think about it. Kind of bothers students, and that's the crusher of a lot of right answers, is because we just have the sign wrong. But this number on the outside for functions cause a shift, a vertical translation, up or down. And that conveniently is exactly the way the sign works. So if you want to go up, you make it positive. If you want to go down, you make it negative numbers. So our job is to take this point right here, which is currently at 0, 0, and we're going to translate it left and then up. So to do that, we put two different numbers in here to cause this thing to move. So what we want to do is make it go left 5. So what we do is put in the middle, to cause it to go left or right, a 5. If you put a negative 5, which is what our brain usually says, it's going to actually shift it to the right. So what you can do is you click try, or you click enter or something, and it moves. Yeah, there we go. So when you click enter, it moves to the right. So it's discovery in that you're mentally recognizing, oh, that was the wrong way. So now you press, I want the opposite. So now it's a positive 5. Oh, there we go. Now we're shifting to the correct direction. I went left 5 now. Now to go up, I need to put a 1 in here to go up 1. So you put a 1, press enter, and then it translates up 1. Now, the only thing that causes this to not be matched up with that red dotted line below is that I need this to reflect and go down. To cause a vertical reflection, I just need the sign in front of this graph to multiply all these y heights to go down. So every y height, these are y heights here, every y height needs to be multiplied by a negative, and then it'll go down. So what I do right here is just click the dialog box there where it will go to a negative, and boom, it lines up perfectly, and I have matched this graph. And so what you'll notice down below is it says, you have correctly done, actually it doesn't, oh, it does it right here. It says, that is correct. You may now press submit. So when you submit it, you get a green check mark, and you did the thing. So this is a discovery activity of learning, trying to recognize how functions transform based on what you put inside the function notation. This moves left to right opposite sign. This goes up and down, same as the sign, and this causes a reflection, and then eventually we'll get in some stretches there as well, or compressions as well. So what we have here is a square root function, and it is supposed to look like this in its most parent form. This is the parent function. The parent is the most basic version of any function. This is the square root one. The last one was absolute value, which is just a very simple v. This one just takes off sideways. It's actually a half of a parabola turned sideways, an inverse parabola graph, but we just take the positive side because otherwise it wouldn't be a function. Anyway, this needs to go right and then down. Well, how far right, how far down? Well, this coordinate right here tells you that touches at 6 here on the x-axis, so I need to go right 6. To change it to go right, you need to put numbers in here opposite of the sign. So to go right, I need a negative 6 to go in there. And then to go down, I need it to go down 5. I put exactly what sign it is to go the direction I want it to go. So negative 5 is the direction. So I actually type those in, and I get to watch it move. It's kind of fun. Negative 6, enter, and it shifts to the right 6, and then down 5. And press enter, and you see it translate down 5. The only issue is I need it to reflect now to match up perfectly with my dotted line. Right now it actually looks like a parabola, and that's kind of what I was talking about earlier, where this wouldn't pass the vertical line test if you had both the positive square root, and then this down here is just the negative square root. So this is what I want it to be to match up, and so I go ahead and type put a negative in there. So I click this, negative, boom, it matches up, and now it says, yeah, that is correct, and you press submit. So again, it won't let you be wrong, which is convenient, but again, we're discovering. All right, so now we're looking at our parabola, the thing that we've done before in Math 2, and hopefully this is actually vertex form is what we're playing with, and shifting it right and then down. And again, all of these that I picked were apparently reflections, so every time we're going to click the negative sign. That's not always the case, but it is on the ones that I selected here for us to play with. So we want to go right 4, it looks like, so I need a -4 to go in this box, and then it needs to go down 3, so I need a -3 over here. So I go ahead and type that in and watch it move. So -4, then click in here, and I need to go -3, press enter, and it goes down, and then I just need it to be my simple reflection, and that is caused by a negative on the outside of the function. Notice again, I hadn't pointed out very well that what's happening along the way is it's actually writing the form of the function correctly based on how you submitted things into function notation. So it was working with function notation, which is how all functions behave, shifting, translating. And then this is actually the vertex form of a parabola and how it would respond if you were affecting the function in function notation with composition the way that we just did. All right, so now check this one out. It's a little bit different than what we were just playing with because we're not actually getting to move the function. What they're doing is they're saying you have a function. It's this one here, that the black bold function. And what's happening is this function is supposed to go down and right. And our job, that this is called f of x. And then it says what function represents the dotted graph. Well, what they're doing is they're giving us some vertex or function notation forms, and our job is to recognize that this is f of x. If this is f of x, we don't even know what it is. I mean, we could make the equation for it, but if that's f of x, what would you do in here to cause it to go right to the x-axis? Well, we want it to go right 2 spaces, so I would put a -2 in here behind the x. So it's going to be f of x minus 2. And then I needed to go down 6 spaces to be right here to match up. So then on the outside, I put -6. So this is what I have to think through to cause the right answer to be selected below. So then I check my options, and then you really only had the option of playing with the 2, so it was just trying to get us to think through, was it a -2 to go to the right or a +2 to go, and the +2 would have gone to the left, so that would have been wrong. So I need a -2, so you only have these 2 options, and then I need to go down 5 spaces from where I was. So that's where we get the -5. So again, keeping it very generic with not actually knowing what the function is. This is a semicircle, and so we're not going to worry about what the function form is for the semicircle right now. We're just going to call it f of x. That's the solid. It is a shifted version of a semicircle, and we come up with the equation for that. But all we're doing is worrying about if that was called f of x, then in function notation, let's cause it to shift and over right and then down to match up with this semicircle. Well, all we have to do is pick any single dot and then map it. And matching it, how far does it go to match up to this dot? Or this top dot, how far does it have to go to match up with that top dot? And same one, this endpoint, how does it get to there? So if you work that, you just have to count from -5 over here. I'm going to match it up with this dot. I just move to the right 5. So I'll say R5 for right 5. And then it needs to go down to this -2. So down, D for down, 2. So if this was called f of x, then on the inside, what I need to do for this function is to call it f of x minus 5 to get this function to shift right 5. That's what you do, is you call it -5 on the inside, and then to go down 2, I would add a -2 on the outside. So if this original function was called f of x, then this new dotted line function would be f of x minus 5 on the inside of the parentheses, and then -2 on the outside. So again, these are not parent functions. They are already themselves shifted functions, and then we're calling it f of x and then deciding in function notation how to get it to shift and work. All right, so one more function like this, we're calling this parabola I mean, we could find the actual equation for this parabola. It's pretty convenient because it's in vertex form, but that's not our job. We're calling it f of x, and we want to figure out what is this function in terms of this f of x original parabola. And this is not the parent graph, but we're shifting from here. So from here, we're just going to recognize, I'm going to focus on especially that vertex right there, that it is going to match up with this vertex. Well, I needed to go left 5 and then up all the way to that height of 3. It started at -2, finished at 3, so it's a left 5 and then an up 5. So to do that, I need to make the inside to go left. Lost connection. Huh. So yesterday it did this and it would not reconnect. So to go left, I need to make it a -5 on the inside. So it's going to be x minus 5. Sorry, to go left, I need that -5 to actually be a +5. That's what I meant to say. To cause it to go left, it's opposite of the sign. And then to go up, I need a +5 also. So this dotted line is going to be f of x plus 5. That causes it to go left. That's the left part. And then up 5 is the +5. So that would be my answer selection down below, +5 here.